Hello, everyone. I'm Sinan Kozak, and I will talk about my journey and our team's journey about modularization. I was lucky enough to be part of 2 different code bases and their modularization effort. So I think I have some experience, or like at least I saw some problems I would like to share with you so you can have better understanding about what you need to plan for the modularization, and most importantly, how you track it and when to stop your efforts. The thing is, I love modularization because it lets me to go deep dive in the code base. I'm able to see other features, what they're doing, why they depend on each other, and it let me understand the code base better. But I also noticed that it's not an enjoyable task for everyone. Because if you don't have any goal that you set as a team, you're not going to have evenly modularized application. You might have a couple of features of your code base modularized, but not everything. So, but first thing first, if you still have a single module code base, if you have solution for your problem, you don't have any code conflict, if you don't have any build performance issues, it's good. You don't need to go and modularize your application just because community says so, or there are talks or blog posts about it. You don't need to do it. But the things will get hairy eventually, because your features will depend on each other. You might have longer build times over time. Not just because you write the code, but also because of libraries that you are using, or the helpers or the frameworks that you are using. On the other hand, you might have a legacy code base that you depend on heavily. Sorry, you don't have any modules yet, but you might have a couple of giant code bases that you think it's modularized. And if you know that you have lots of features in the same module, which might be the app or a second module, that also is OK. The thing is, if you know how to overcome your problem, if you think there's no problem about your code base, that's good. But we know the reality. Your build times are probably longer than your lunch time, and I know people are playing video games. I know people are preparing coffee while Gradle tries to compile their application. But it's not good for our time. So what problems modularization can solve for us? First of all, code conflicts. There will be more separation of concerns, and there will be more separation per feature that will help us to have less code conflicts if you're working on a big team. Just because you're working on your feature in your module, you will be ensured that you're not going to have any conflict. It will reduce the high coupling. We should always aim lowering the coupling, but if you have a single module, there's nothing prevent other developers to depend on your features. Let's say, I'm pretty sure everyone has a login feature, and I'm pretty sure lots of other features depend on the login, while also being able to start the login screen and everything. But that's not great. And probably there is no clear ownership about who owns the which screen, and when you change a class, who's going to own that, or like if you created a problem in the code base, who's going to solve it? And most of the helper class will be orphan in the code base. And again, longer build times. I wanted to emphasize that longer build times probably the last item for modularization, because there are other tricks that you can do, but the major benefit that you get out of the modularization is not build time. Build time will eventually come, but the thing is, you shouldn't put the build time as an immediate goal, because you might see the results like in 6 months or 1 year later when you have a good modularized application, depending on your scenario. But are we going to modularize all the things? Are we going to split all of the code that we have? We definitely need a layering strategy. And when we think about layering, we already have architecture in our applications. We are using MVPs, MVVMs, MVIs. So maybe it's a good idea, or it may be an idea to use that layering for modularization. There are suggestions to do so. But that means we might have view, presenter, model, network, domain kind of modules. But what needs to be a module? Are we going to have a single domain and a network module for the rest of the application? Or are we going to have a domain module per feature? So if we start thinking about it, we are going to have lots of different modules per feature. It sounds a little bit granular. And when you just want to create a new screen in a new module, you're kind of increasing your efforts to add a new feature rather than simplifying your task. So we need to define what is a good modularization layer. Actually, my own idea is like, so that solution that you're going to use must give you the best possible build performance while creating isolation between features. And that's all what you need to think about. You don't need to follow a suggestion that is just because a giant company is using. Because when you read blog posts or when you listen a talk from a giant company like Twitter, Google, or other ones, they have different kind of problems. They might have thousands of different modules, and they might require different solutions. But if your code base is mid-size or small, or like, let's say big, your problem is not going to be same as that. So define your goals, define your problems, and not just copy what community is doing. And there's a good talk about what you can consider as a baseline. And again, in a DroidCon, San Francisco, from Square. But this is a good startup for understanding what the layering is. The idea is it's better to keep features implementation hidden and have public APIs so other features or modules can depend on or use the exposed part of your feature. My suggestions on this topic, and this was a similar suggestion that we use in the code base I worked on, have public APIs per feature. So if you have a login, rather than have everyone depending directly on the login implementation, create an interface and put that interface in a different module so everyone can easily use this one without depending on the implementation. You can have multiple implementation modules per public APIs to satisfy your need. In the public API, you might expose a repository or network layer or whatever you want to do. You can create different layering, but it will be your requirement to do so. So you shouldn't force anyone to create multiple modules for their feature. If their feature is small enough, they can also use a single module to implement all of the public APIs. Basically, your team members or like your squads will be a smaller part of your company that's working in isolation, but only exposing the contract. And since you have public APIs and you are writing your tests in the implementation module, you can create fakes for those public APIs so others can use without depending on your code. One example, let's use the database again. If you write your test for your database, there's no need for other modules to initialize that database or use a real database while running the test. You can always provide a fake implementation or in-memory version of it to simplify others' test effort and create or have almost empty app module. So app module will get compiled no matter what, because that's the part that our code base and Gradle creates the APK. And if we think about if your feature will be in the implementation module, and you are going to depend on a couple of libraries. So best thing that we can have, like 3 layers of dependencies, and when you change a line of code, your module will get compiled, an app will compile. And if we don't have any code in the app, only a couple of configuration, app is going to compile quickly. If there are some code generation libraries, they will generate code, and then it just needs to package it. So any improvement that you're doing in the app module will be beneficial for everyone in the team. But what is the goal of modularization? So we want boundaries between features, but how many modules per team is enough? How granular you want to go? We want to have better build times, but how fast is enough? If we give 1 minute build time to someone that is used to 10 minutes, which will be an immense improvement, but maybe we should put a goal about like 30 seconds, 10 seconds, Because every second we are trying to shelve from there will be an extra effort that we need to take. And also, when you have boundaries between the features, you will be able to create isolated tests. But at what cost? So there will be definitely a setup cost for the isolated test. You need to spend at the beginning of your modularization effort. But always check with your company and check with your priorities. Because it's good to have isolated tests. It's good to separate the UI test in the different modules. But you also need to keep maintain and keep adding those features in the future. So possible metrics to track. You can track how many lines of code you have per module. But it's not going to be a good metric, because if you just look at the average number, it will be an outlier. You should always aim to have an evenly distributed code base, and always aim to split the big modules into the smaller, useful, reusable parts. Otherwise, that metric is not going to help. About the build time, you should create repeatable build scenarios. Like, hey, what happens if I change a line of code in an implementation module? Well, what happens if I run a clean build? What's going to happen when I run the test? And those are all scenarios that you can create with the Gradle profiler and run on the CI periodically to collect the data. And you can compare over time. The easiest way to find out what is your status with the modularization is also creating a visual graph that represents your dependencies. And you will probably see that some part of your dependency tree might have longer parts and might have longer leaves that they have. So the idea is keeping the dependency depth small as possible is important, because when you change a code, you just want your module to get compiled and app module to get compiled. When you change a code, if other modules get triggered, it's going to be costly. You're going to pay with the build time. And the CPU utilization. Nowadays, we start getting new MacBooks with the 10 core, and you might have more CPUs or core at home with the desktop or with the CI solution that you have. So the CPU utilization is important, because we are able to compile parallel. The idea of creating modularized code base will let us to compile different modules in parallel. So we need to take a look at the CPU utilization over time to see what kind of improvements we can get. And the Gradle Enterprise and the Gradle can give you this number, how much utilization you are getting. And on my previous company, we had like 4.7 CPU utilization, and we were thinking that it's a good enough, because most of our employees back in time had 4-core or 6-core laptops, and on the CI we had already 6-core CPU. So the 4.7 felt like the good way to stop, rather than increasing, making sure we will have maximum CPU utilization. And this is a sample timeline from our project from last year. So we already had modularized code base, but that doesn't mean that we will get super build times, right? So when we look at the timeline, we easily notice that there's one giant module that depends on lots of other dependencies, and the app module also needs to wait for that giant module. So what happened is, half of the time, we were able to utilize the CPU. We were able to get maximum out of our hardwares. But for last 40% of the build time, we are just waiting on a single thread and a single I/O operation, and everything needs to be done because they depend on each other. And this is our current timeline. We still definitely have room to improve. There are empty spaces that we can utilize. But for a clean build, this looks okay. So we decided that, hey, this kind of looks okay, and from now, the teams will work on the modularization themselves. So in the future, we will have more granular modules, and this graph will get improved over time. But the idea, you always need to keep eye on what's going on when we talk about the parallelization, because it's not coming free. You need to make sure that you have correct dependency tree. What were our goals when I worked on those modularization. One, maximizing the CPU utilization, because that's a metric we can keep track on. And making sure we have a flatter dependency graph to reduce the dependency depth that we have in the graph. We had a dependency tree leaf over 15 modules, and there, you can imagine that there were profile, logins, old legacy codes, a core, and other libraries in that one. So whenever you start depending on the profile, you immediately start paying the cost of all other dependencies. So if someone changed something in the profile, if someone changed something in the login, they're going to trigger lots of other modules to compile, and it was interesting to see complaints from the team members, because they were saying, hey, I'm working in my feature. When I press compilation, I'm seeing that this unrelated features also get compiled, because you don't expect another unrelated code base to get compiled. So that was also one of our goals. And increasing the isolated UI test count. This is an interesting point, because technically you can create all of your UI tests in the app module with the real implementation. But when you start thinking about, hey, we have isolated features, it's also a nice idea to move your test into the smaller feature modules so you can run them separately rather than running everything in the application module. That will help you to run your test locally, but in the end, it might increase overall build time, because when you have 20 different features, they also need to create APKs, they also need to create test APKs, and they need to compile their Android resources. All of them come with a cost. So not everything you are going to do is going to improve the build time. So you need to look eye on your metrics when you start doing those kind of things. But where to start? First of all, you can write a convention plugin. Gradle supports writing a plugin for your modules so that you can share your custom configuration with all of the modules that you have. And you should start slowly. First of all, you can start with setting minimum target or compile SDK and making sure that all of your modules use your plugin. And then, one by one, you can reduce the custom configuration that you have in your module. And I suggest you should write your plugin in an included build rather than build source folder, because it is more beneficial to have included build over build source. There are great comparison, and even Gradle itself suggests using included builds, because when you write your plugin in the build source, anything that you are going to change will invalidate the cache, and anything will change, invalidate the syncing and the configuration phase of the Gradle. And it will be costly over time, because you won't notice when you start adding the build source. It might look fancy, but I suggest everyone should migrate from build source to the included builds. And this is what we aim to have. In your module, it should be simple as, hey, we have a custom plugin that sets up everything for us, and those are the dependencies. I'm ready to write some tests. So I'm ready to write some code. So your team members should easily start a module like this and shouldn't think about what I need to set up in the Gradle, because Gradle itself, even with Groovy or even with the Kotlin KTS, it's a different world. And if you are just learning Android, or if you didn't get any training or didn't get educated about the Gradle, it's like totally different world. And if you don't want to learn it, it's okay. And you need to help your team member to achieve a greater outcome by helping them being able to create modules like this. But at some point, modularization effort needs to stop, right? And when to stop? You might think maybe 10 is a good number, 100. Maybe you heard that Square has 3,000, Twitter has 2,000, or something like that. So is this a good metric to track? I can say number of the module is not a good metric to track. I was in conversations between different developers. They were comparing, hey, we have 200, hey, we have 500. So it's not something that you should directly compare, because it doesn't give any context about what you have. And when you might consider stopping at some point and start working on the maintenance and the modernization of your code base, which might your team get more benefit out of it. Because when you have a good foundation, it will be easier for the rest of the team to follow your modernized code base. Because the moment you start more modules, the moment you find a pitfall, all of your modules will hit that pitfall. So the more modularization is not going to solve all of your problems. It will actually create different problems that you need to solve. You will hit a different roadblockers. And it's important to think about when to start thinking about the solution. And I suggest the moment you find a different problem, slow down and work on that solution rather than continue with the modularization. Why? Because other team members will find workarounds or other kind of best practice to overcome this solution. The bad side of it, it will, like everyone else in the team will use those workarounds, and it will spread like a plague. And you won't be able to easily migrate your new best practice or your new solution when you decided to refactor. So it's better to have a solution-based migration at first rather than postponing the solutions. And create a template module. It will be empty with a basic. It should be empty, and it should just have the basic Gradle setup. And the idea is your team members should easily be able to create a new module without thinking what they need to create. Manifest and or like Gradle files or the test files, all needs to be there for them. You can also create a Gradle task that does this the application or this copy pasting for you while also adjusting the package names and other kind of stuff. So there are also like really good blog posts that's describing how to do it, and I'm hoping that we will see more sample template modules in the community as well. But the other thing is configuration. You all know the Gradle needs to configure the Gradle task. And the more modules we are going to add, there will be more things to configure. Every new module comes with lots of new Gradle tasks generated automatically by the Android Gradle plugin. So the more code, more modules there you are going to increase the configuration time. And there's a solution for it using configuration cache. You might need to update most of your libraries to support configuration cache, but you can easily cut 20 seconds, 30 seconds, or even 1 minute from every build that you have. So that's a low-hanging fruit that everyone needs to use. And the other one is the namespace R files. So every new module will create their own R file for their resources. And the idea is, in the app module, at the moment, you are able to see all of those resources, right? We are used to that idea. Our file will have the resources that I'm depending. But it actually comes with a cost, because then compiler needs to create an R file by looking at all the dependencies they have and merge their R files and their resources in a new single R file. And that will go on until we reach to the app module. And it's costly for memory, it's costly for the CPU, and it creates coupling between resources. So named R file is a new feature that comes with Android Gradle plugin. It will enforce you to specify which R file you want to use from which module. And it will compile those R files only in those modules to simplify. It will help your build times, but you also need to change your mental model about how you think about the resource or how you are distributing the resources. And the more modules that you add, you might get better incremental build times, but again, you also need to keep eye on the incremental build times and the cache usages, because we want to maximize the cache usage as much as possible, and we would like to do compilation avoidance as much as we can. Because in Java world, when we want to compile something, it is not snappy like JavaScript or Go. So we need to, not to Go, so Python, or other languages. So we need to make sure that we are able to use already compiled cache as much as we can. And you will encounter lots of cache issues in your code base or from the libraries that you're using. There is a good library for fixing the common cache issues in Android, cache fix library. So the idea is, even in the tools that we are using, like let's say, room, Android Gradle plugin, there might be bugs that we are waiting for fix in the next feature, the next release. But Gradle is a flexible tool, and those good developers of Gradle are trying to apply the workarounds to the older version, so you don't need to update your Gradle plugin if you don't want to, because it's also a costly thing to do if you have a big code base. And if you can, also use the scenarios that you created and find a way to have a build regression. So we created monoliths of module, and those modules are hidden. They do not see each other. But how we are going to navigate? So that's kind of like the big problem when you start navigating. Because the activity navigation depends on intent, and intent needs to have a class instance, like a class path, class definition, or the class path. But since you don't know where that activity is, you also don't know, is it an activity or is it a fragment actually? You might think, hey, I can use deep link or app link. That's a solution to do navigation interconnected. But then how we are going to pass the input? Because with the deep link, you won't be able to pass parsellables. So if you already have an input as parcelable object, you won't be able to do that. And what about the animation? Because some activity might require shared element transition, and you also need to pass this information. With deep links, I think it's not possible. So you might be thinking, hey, there are lots of problems that we are creating that was easy to solve before the modularization. Yeah, that's true. But the thing is, we talk about the public APIs already. So you can expose this intent or deep link or whatever navigation solution that you want to have and expose that one in your public API. So the others will get the destination or the name of the route or whatever you would like to call from the public API of your feature. So they really don't need to depend on or know about where to navigate. You can easily write a lint rule to find out, to prevent people to depend on activities and let them to only use this kind of information in the implementation module or not let the people to depend on cross-feature activities. And it will help immensely because you also need to change the mental model of the team. Everyone needs to think about, hey, when I would like to go from feature A to feature B, where I don't know, and I also shouldn't care about where I'm going because I need to say that, hey, feature B, give me your path, and I will call it with the start activities or depending on the destination that's returning. But a fragment navigation has different problems. You might have multiple fragments in the same feature, or you might want to go to different fragment in a different feature. The solution for the first one is kind of easy. You can use whatever you are using. But going a different feature fragment is a difficult one. And if you are using Android X navigation, XML solution is not going to work because in the XML, the library expects the full path of the fragment. And it tries to create destinations, actions, and the necessary class with this information. But since you are not depending the feature B, you won't be able to put the full path over there. Compiler will say that I don't know this class where it is, even though it's in your class. And in that case, you should use navigation graph DSL, and you need to create your navigation graph in the code rather than XML. You will lose some features like automatic action and destination creations, but there are also libraries in the community to help you regenerating similar classes. But on the other hand, navigation graph DSL for the fragments also suggests using deep links. And if you want to pass a user ID, sorry, a user data, they suggest rather than passing the parcelable user, just pass the user ID, and the next fragment will fetch the user from the repository again. So if you have cache in the repository layer and everything is snappy, it's actually a good suggestion, right? Because then you will encapsulate your fragments. They will depend on less input, and for example, your test will be simpler because you just need to start your fragment with a single input rather than giving a giant input. Also, one important problem is that you might find that you have lots of modules, but they do not give any context with their name. So I suggest common, core, base are not the good names at all. Do not use them. Do not let your friends to use them. Because when you start a common module, you might have an idea about what you're going to put there with a good intention. But the next week, your team member will create a class, and they will not know where to put it, and they will put it in common. So rather than having even a modularized, reusable code base, you will create smaller monoliths in your code base, in your features called commons or cores. So always think about, hey, I'm creating a class. What is the purpose of it? I should give a purposeful full name. Because next time when you go there, we also want to find it rather than thinking, hey, let's put everything in the common. And this is also, like, there's also elephant in the room, which I think everyone has an old legacy code base, and we won't be able to get rid of them easily. So we need to spend some time to split reusable parts into different smaller modules and making sure that we are showing some love to the legacy part of our application. And the rule of thumb, if you like to go with the modularization, when you're working on a new feature, always start with the new module. Starting a new module should be easy for your team members or for yourself. So when you think about, hey, I'm going to add a new screen, so there shouldn't be a question where I'm going to put it, because you need to create a new module for it. When you compile your code, only your feature and the app module will get compiled, and you will have better development cycles. And you can help your team members to visualize the dependency graph you have. There's a good library dependency graph generator. It's a plugin, Gradle plugin, looks at all of your dependencies and and creates a graph that you can investigate and share with your team member or the stakeholders. What is good about it? You need to aim to have a flatter dependency graph. So if you have an ideal code base, that graph will be almost impossible to investigate without any zoom, because we don't have enough, like wide enough screen to look at the moment, even though we have a wider one. And there are lint checks for Gradle that you can impose on your code base. And those lint checks might look at unused dependencies, unused plugins, and warn you about what you can save. For example, if you have cup dependency, but not using any cup or dagger or something like that in this library, this plugin will let you know, and you will remove it. So there will be less Gradle tasks created, and there will be less configuration time. So overall, those are like small saves, but in the end, when you start having 100 or 200 or 500 modules, those small saves will be beneficial for having a top-notch build times. And the graph assertion is also an important one. Unfortunately, it doesn't work all of the code bases, so it didn't work one of the code bases I had. But the idea is it has some assertions that you can impose your code base. Like, you can give the maximum dependency depth, and if someone mistakenly increase that dependency depth, that assertion will fail. Or you can give rules like an implementation feature shouldn't depend on another implementation module. So depending on the name scheme that you had, with the purposeful name, you can create those kind of rules with the help of these libraries. But where to start? I suggest, if you didn't already start or if you didn't already do, move all of the codes in the app module to the base old legacy module, and all of your new features will be able to depend on the app. But the idea is you shouldn't let that app module to leave. You need to extract as much as possible. Whenever you go and use a string util or whatever it is, just extract it to the new module and help your team member. All of the new features are good candidates to start, because it will be easier to add new features with a new module rather than refactoring the old one. Because while refactoring the old one, you also need to make sure that it's working as expected, and if there's no test, it won't be fun to do. And what you will get out of this one, you will have faster delivery with less conflict, and with the purposeful name, you will get clear ownership. Just by looking at the name of the module, you should be able to tell, hey, team A owned the feature A, and we need to get a public information from their repository. Let's go talk with them, or I'm going to add this information to the public API while pairing them. So there will be more clear boundaries between the team, and this will also help to keep the communication between the team healthy. So the summary is, modularization is not just a buzzword, or it's not a necessity. It's a mental model that you should have. And you should have this as a team, because having this kind of effort as a single person is not doable, and it's not healthy for a single person. So I beg you to help. If you have someone in your team is doing and pushing for modularization, help them, because when they improve something, you benefit too, and it's a team effort. I find it like I'm playing puzzle or like solving a riddle, because every time you touch an old feature, you find an old workaround, or you find something interesting from 5 years ago, and you try to understand what were they thinking. And creating new modules should be a habit, and it should be easy. And you always need to be careful about not to end up worse than what you started with. Because like I said, modularization is not the solution. You need to keep eye on it. You need to have metrics to look at. And without looking at those metrics, you might have something worse, and in the end, in the 1 year later, you might need to explain why the build times are much worse than where you started to your manager, and that won't be a good conversation, I guess. And always track your progress. That's important, and you always need to know when to stop, like I do. This is the end. Thank you.